Friends, so in this particular video, we are going to look at mechanical properties of iron carbon alloys. When we talk about mechanical properties, the microstructure of the corresponding iron carbon alloy is of great significance. So, the type of microstructure inside an alloy will decide or will give us a good estimate of what are the mechanical properties or how mechanical properties of the particular alloy will look like. So in the last videos we have discussed about what are the different kinds of microstructure that we will get after doing a lot of thermal treatments for an iron carbon alloy. So we have already discussed about quite a few of those microstructures. So to name a few, fine pearlite, coarse pearlite, bayanite, spharodite, martensite. In the earlier lectures, I have explained how these microstructures are formed and what are the particular characteristic of these microstructures. So in this particular video, the emphasis will be on the mechanical properties of these particular microstructures, or in other words, so you have an alloy and in the particular alloy you are seeing this particular microstructure, then you should be able to predict or you should be able to give an estimate about the mechanical properties of the system. So system in the sense for that particular alloy. So going ahead, first we will start with fine pearlite. Having said that, the microstructure has a strong influence on the mechanical properties. Now, the first microstructure we will look into is pearlite. So there are both types of microstructure within pearlite. It can be either fine or coarse. So as you can see here, so this is a coarse pearlite where you have very thick lamella of Fe3C or cementite, but once we come to very fine pearlite or fine pearlite, for that say it's not called very fine pearlite, it's fine pearlite. So when we come to fine pearlite, as we can see here, these Fe3C lamella are not that thick, they are very fine, so these are called fine pearlite and this is called coarse pearlite. Now we will start off with doing a thought experiment with the fine pearlite microstructure. So as we add carbon concentration, that means there is a more chance of creating Fe3C, which is cementite, in the microstructure. So when we add carbon, more and more cementite will be produced or Fe3C will be produced. Now, what are the properties of Fe3C? Fe3C or cementite is very hard, it's very strong, and on the other side of the coin, it is very brittle and its toughness is low. So if we perform this thought experiment of increasing the carbon concentration in a fine pearlite, then the tensile strength will go up, hardness will go up, similarly yield strength will also go up. The reason for that is when you add more carbon, more cementite will be formed, and cementite is harder, stronger, so that's why we see this kind of a trend in fine pearlite. Now we looked at the effect of carbon content in yield strength, tensile strength, as well as in hardness. Now, what will be the effect of increasing the carbon content in a fine pearlite microstructure on the mechanical properties like elongation or ductility and toughness? So in this particular curve, this represents toughness, this represents the energy from an ISO test, and this represents the ductility expressed in terms of percentage elongation. So this figure clearly demonstrates that as you add more and more carbon into it, your alloy becomes less ductile, less tougher. This can be attributed to the fact that as you add more carbon, more cementite will be formed, and cementite is less tough and cementite is more brittle. Clear? So we have just looked at, in pearlite there are two variants. One is fine pearlite, the other one is coarse pearlite. Now among the two, naturally a question arises, which is more stronger and which is more ductile? Before answering that particular question, we should understand what is the mechanism that actually gives this particular microstructure the strength. So the first point in that regard is, let me use a different color. Cementite will reinforce or will act as a reinforcement in the ferrite matrix or in the alpha matrix. So how is that happening? You may have heard of carbon fiber reinforced polymers, in which a fiber is kept in an epoxy matrix so that we will get very good properties. That is how carbon fiber reinforced plastics are working. So the fiber will be much stronger and harder, while the epoxy will be ductile, it will be soft. So similar to that concept here in pearlite also, here we have a very strong rigid cementite phase, and then we have a very soft and ductile ferrite phase. What happens is, this strong and rigid cementite phase will severely restrict the deformation of the ferrite phase. So in that regard, it will give more strength to the alloy. So you can ask me, what can be a good measure of this reinforcement? So the reinforcement or the amount of reinforcement is directly proportional to the interface area or the phase boundary area. This area, this is the phase boundary area. So in which of these figures we have more phase boundary area per unit volume? Obviously, in fine pearlite, we have more phase boundary area per unit volume. So, that is one reason why fine pearlite will be more stronger. There is another reason as well. We know plastic deformation usually happens in a metal because of the movement of dislocations along the slip planes. Now what happens is, here these phase boundaries will act as a barrier against dislocation motion, similar to grain boundaries against dislocation motion. So these are the two things or two mechanisms which will decide or which will have a strong influence on the strength, ductility and hardness of the particular parent alloy. So from this figure it is very clear that fine pearlite is more stronger because you have more phase boundary area. On the other hand, it will be less ductile because it is having a strong resistance. It is showing a strong resistance against plastic deformation. So this will be less ductile compared to a coarse pearlite. So thanks a lot. So we have looked into pearlite. In the coming, we have discussed in detail about pearlite microstructure, and in the next video we will have a look at the spheroidite microstructure.